depolarization that is strong enough to reach threshold, and that is going to depolarize this portion of the membrane, which is then going to depolarize the next and next and next. Okay, so ready? Stimulate. There we go. Very nice. That's essentially what is happening in the action potential, which of course is going to put a whole new spin, and you see that at your next sporting event, right? That's okay. So essentially, this depolarizes. The current moves to the next area, triggers the threshold here. That depolarizes, causing depolarization, depolarization, depolarization. Right? That's how action potentials are propagated down non-myelinated axons. Let's see that again. Right? Let's go next here. Exactly. It's a very laid-back kind of action potential. Yeah. Okay. All right. Okay. So that's how it works. Now I'm going to challenge this particular axon, because we're assuming that we're recording, or we're starting at kind of the axon low, right? But sometimes, maybe if you bang your elbow, you get like that, you hit your funny bone in your own nerve, and you can mechanically stimulate, or you can electrically stimulate nerves in the middle. Now, if I were to electrically stimulate this nerve in the middle, what's going to happen? Let's see if the nerve can figure it out. Okay, so here we go. Zap. Is that what's going to happen? So which way did it go? One direction? So we're... It would go both ways.
Oh, really?
Yeah.
No, I didn't.
Yeah, because you're not refracted. Right? Ah, not refracted. Let's try it again. Zap! Okay, so it will spread out from the center outwards. Right? So it will travel still in one way. You think, well, don't want you contradicting yourself. Well, no, I'm not. It still travels in one direction each way, but it's not going to back up. So it's not going to move. Okay? Does that make sense? You can do that because where I'm stimulating, these areas are refracted. Pressure.
So if it goes both ways, would it switch? The stimulus will still terminate when I have to then for the pillow part because there's no like.
Right. So if it travels that way down to the axon terminal, it'll do whatever happens at the axon terminal, whether it's a muscle or whatever. This way it'll travel up to the axon hillock, and then it'll essentially stop. Okay. Does that make sense? Okay, I'm going to challenge her to one more. Yes, oh, another question.
I was wondering, at what point in the action potential do I stimulate my neighboring regions? Like, is it when I'm at the top that the others start opening, or do I go start repolarizing before they?
Okay, so the question is the timing of when the action potential stimulates their adjacent neighbor. It's probably very rapid because almost, no, it doesn't really matter. It's probably very, very almost simultaneous. Almost. Okay, so what I'm going to do this time is I'm going to stimulate. Hope you're not running out of space there. Okay. So what I'm going to do this time is I'm going to stimulate both ends of our axon. Okay, simultaneously. My arms aren't that big, so you're going to have to pretend that it's not really. Okay. So ready? There's a position there, and stimulate. Is that what happens? Action potentials traveled in each direction and stop. Is that what's going to happen, or would they reach the middle, go double the height, and then go back? Which one would happen? Yeah, it's going to stop, right? It's going to reach the middle somewhere. You'll have one action potential. Is it going to be double height? No, all or nothing, right? And then it's going to stop because these areas adjacent to it are refracted. It's not going to go in the middle and that quickly. So it will stop in the middle. Is there a question? Yes.
Yeah, so when you stimulated the middle of the neuron, if it's one neuron, does the potential go backwards towards the membrane and one goes to the hillock?
Yeah, it will travel in both directions. Yeah, question. How exactly would you stimulate the middle of the neuron? You could electrically. I'm kind of pretending I'm doing it electrically. Yeah. So some of you were doing the lab course and you're electrically stimulating. That's exactly what you do. Question.
Is the reason that you can't get double height because of the equilibrium potential of sodium?
Is the reason you can't get double height in your action potential because of the equilibrium potential for sodium? It's because the action potential is all or none. Remember, once you fire the action potential, the sodium channels are all going to open, and you're going to inactivate fairly quickly, and then your potassium voltage gated channels are going to open. So you can't get something that's double height. Does that make sense? It's all because of the opening of the sodium voltage gated channels, and then followed almost immediately by the opening of the potassium voltage gated channels, because they're going to try to make it rise. You have to essentially leave your potassium voltage gated channels or sodium voltage gated channels open longer to get that double height. So it won't happen. It's all or nothing. Right? Does that make sense? All right, let's give a round of applause for our fantastic background.